Measurement, and it's important to recognize that you'll be doing a lot of measuring over the course of this year, so you have to be very comfortable with how we use measurement and how we view measurement. First of all, you should be familiar with the International System of Units, which we call the SI units, that will be used for a variety of quantities. Not all of them will be used in chemistry, but you should still be familiar with the actual SI units for each quantity that we'll be using. The other thing that you need to be aware of is that we have a series of prefixes that make using these units very convenient. So make sure that you are familiar with the most common prefixes that we'll be using. I would at least recommend you are familiar with these 7 here. It will just make calculations a lot easier for you. The relationships that you have to be aware of are important as well. So make sure that you know what a liter is, what a milliliter is. Know that 1 milliliter is the same as 1 centimeter cubed on each side. You also have different measuring devices, all for the same type of quantity, such as volume, but it's important to recognize that each device has a different use and a different amount of accuracy, so that's very important. The relationship between the temperature scales is important, particularly to remember that we need to use Kelvin for any calculations involving gases. Also, just to be sure that you're aware, Celsius is the unit that we would use for measuring temperature. Kelvin, again, is the SI unit. It's based on the fact that it has the lowest possible temperature set for 0, so that there are no negative Kelvin temperatures. Going back and forth between Celsius and Kelvin is rather simple. You just take the Celsius and add 273. Going between Celsius and Fahrenheit, a little bit more complicated, but there are formulas there provided for you. Density is a physical property of a substance. Let's talk a little bit about significant figures. So significant figures is a term that we use to refer to the digits of our measurement. We say that all digits are certain except for the last digit, which is estimated. So we always want to round off our calculated answers by paying attention to the significant figures so that we do not make our results to appear to be more accurate than the measurement or the equipment that was used in that particular experiment. So you need to be aware of the rules for significant figures. So all non-zero digits are always significant, and then zeros that are between 2 significant figures are also significant. Zeros that begin a number, so that you have, let's say it's holding a decimal place, those are not significant. And then if there is no decimal place, then zeros at the end of a number is not significant. But if there is a decimal place, then they are. The rules for what you do with significant figures when you add and subtract. You need to remember that the position of the decimal place or the number of decimal places is the most important thing, and you have to round your answer to the least number of decimal places. When multiplying and dividing, you round your answer to the least number of significant figures of those used in the calculation. So 2 different rules there. Also, in regards to accuracy and precision, just remember that accuracy has to do with how close the measurement is to the true value, whereas precision refers to how close each of a series of measurements are to each other. So if there's something wrong with the equipment and it's not calibrated properly, you could get the same answer and over again, and your answer would be precise, but it would not be accurate. Dimensional analysis is a very important technique that we use to convert one quantity to another. This is something that you should still be comfortable with from your previous course. Basically what involves is what we call a conversion factor, where two quantities are equal to each other. We can put one over the other as a fraction, and then it's like multiplying by 1. So we're not changing the value of the starting quantity, but multiplying by that conversion factor. You start with the given number in unit, and then the desired unit of the conversion factor would go on top. The given unit of the conversion factor would go on the bottom, so that those units cancel out and you're left with your desired unit. So for example, if we wanted to convert 8 meters to inches, we can convert first from meters to centimeters, knowing the relationship, and then from centimeter to inches, knowing that relationship. Okay? Thank you very much. I hope this was helpful. Bye.